Hello, my name is Donald Garrity from SeaParks Consultancy. Today I'm with my colleague Dominic Berger, and we're going to discuss SeaParks BW migration tools using our customer Grundfos as reference. SeaParks has developed 5 SAP BW migrations tools. DECOM4, which is a BW rapid discovery tool, D2, which is a BW decommissioning tool, Val4, which is a testing tool for BW for HANA migrations, Val4 3.x, which is a testing tool for 3.x to 7.x migrations, and finally TunnelSphere, which determines the BW migration scope for a BW solution to DataSphere BW Bridge. Today we're going to discuss in detail 2 of the tools, DECOM4 and D2. DECOM4. So DECOM4 is a BW rapid discovery tool. Our first interaction with any of our BW customers is actually to execute DECOM4. What this gives us, it gives us a very detailed overview of the current BW system. So if you can imagine a BW system is around for 20 years, there'll be a lot of functionality that's not being used in the system. SeaParks has executed over 40 DECOM4 assessments, and on average 50% of a BW system is not being used. DECOM4 highlights BW objects that are loaded, have no data, no user executions. And this is based off all BW statistics and core metadata tables. One thing to note about DECOM4, we don't require transports to be applied to the system. We actually don't require system access. What we do require is 8 files from the BW system. They being BW for HANA Readiness Check Report, 4 standard BW tables, 2 statistics reports, and 1 application monitor for an SD14 transaction. As mentioned, we're going to use Grundfos as an example. So here is Grundfos' DECOM4. With each DECOM4 execution, we produce an infographic. This is Grundfos' infographic. You can see we give certain insights into their BW system. So if we take the first insight, which is a 3.x object, this is extremely important if customers are looking at doing migrations from BW to BW for HANA, and some of our customers are doing an in-place migration. What this means is that there's actually 2 migration projects that would be required if you're thinking about doing an in-place migration to BW for HANA. The first project will be to get the data flows from 3.x to 7.x, and the second project is to migrate them from 7.x to BW for HANA compatible objects. You can see in Grundfos' case, they have 7,231 3.x objects on the system, with 56 3.x data sources being executed, and 39 of them are master data. So in this case here, if Grundfos was moving to BW for HANA, they would actually, and doing an in-place migration, they would first have to migrate those 56 3.x data sources to 7.x. The next insight you can see is the 7.x data sources. You can see that Grundfos is using 1,397x data sources, with 458 to 7x data sources with no data loads in the last 2 years. That's about 33%. Why is this an insight for BW for HANA migration? In a sense that you only want to migrate 7x data sources to ODP data sources that's currently being used. If you look at the next 2 insights, the InfoCube and DSOs, you can see from an InfoCube perspective, 1,101 InfoCubes, 527 InfoCubes with no data extractions in the last 2 years, 48%. And from a DSO perspective, 1,387 DSOs, with 675 DSOs with no data extractions in the last 2 years, 49%. So in the region of 50% of InfoCubes and DSOs have no data extraction in the last 2 years. From an InfoSet perspective, you look at 153 InfoSets with 104 InfoSets with no BW user executions on them in the last 2 years. On the right hand side, you can see multi-providers and composite providers. Again, we'll be using the user executions as a reference. So you can see 451 multi-providers with 96 multi-providers with no BW executions in the last 2 years. And from a composite provider perspective, we have 179 composite providers with 66 composite providers. That's 37% with no BW executions in the last 2 years. The next insight is APDs. APDs are not supported on BW for HANA or DataSphere. So you can see in this case here, Grundfos has 141 APDs, with 37 APDs with no data extractions in the last 2 years. That means that if they're looking at doing a migration to BW for HANA, over 100 APDs would have to be potentially redesigned on the BW system before the migration would happen. The last two insights on DECOM4 are BW query executions. So you can see on the Grundfos system, they have 2,803 BW queries. And the first insight is to say, well, 183 have no BW user executions in the last 2 years. And the second insight is that 1,771, which is 63%, have less than 100 user executions in the last 2 years. This insight, this customer actually, Grundfos looks after the housekeeping of BW queries pretty good. We've seen other customers where that last 2% on BW query executions, a higher number. The first one with no user executions could be up to about 70%. And the second insight with less than 100 user executions is sometimes up to 95%. Now I'm going to hand over to my colleague Dominic, who's going to discuss D2.
Thank you, Donald. Yeah, so my name is Dominic Berger and I'm going to present our D2 tool. And basically the reason why we have developed this tool is that when a client wants to actually decommission unused objects in their system, previously we had to work out manually the dependencies between the objects. And that's why we have then started to look into D2 to automate that process. And the starting point for D2 is actually the output of DECOM4. So as you have seen previously in the DECOM4 for Grundfos, they had quite a number of multi-providers and composite providers that were not used in the last 2 years. And those are then basically plugged into our D2 engine to then produce result files that I'm going to share in a minute to show the customer which objects can actually be decommissioned. So before we go into the result file, there's two terms that we had to come up while we developed the tool. First one is keepers. So basically a keeper object is basically an object that is used across different data flows in a BW system. And of course, if it's used also in an active flow, it cannot be decommissioned. So we keep those separately, and the engine actually recognizes those and then stops the dependency discovery at that level. The second term is floaters. And basically floaters are objects that are not linked to any composite or multi-provider in the BW system. So examples for that, basically switched on business content or prototyping where the objects are just kind of left on their own in the system. So we also address that with our D2 engine. The way that basically D2 works is that we extract about 40 plus metadata tables out of the system. We don't need any add-ons installed or any kind of transports. We need access to the system, but once we have extracted those metadata tables, we can actually build the engine and then start the process. So I'm gonna just share my screen and show you an example of D2 for Grundfos. So as I mentioned before, basically the starting point are the unused composite and multi-providers that have then been reviewed with the customer. In this case, we actually had 83 composite and multi-providers that we used as a starting point. They are listed on the left-hand side here on this summary page. And basically the immediate insight is that on the right-hand side, linked to those 83 providers, you have more than 1,700 objects that are linked to those across those different object types. Yeah, there's more than 30 object types, and immediately you can see there's quite a number that actually are linked to those objects and can potentially be decommissioned. So the first step is reproduce that file and share it with the customer to be reviewed. All of those objects are listed in this objects to be decommissioned sheet. Of course, it's quite hard to then review all of those at the same time. That's why we have come up with this mechanism at the top where you can actually focus your review on a specific provider. So As an example, I'm just going to type in 1, apply this filter here, and immediately the number goes down to 10. It's a very simple data flow with a multi-provider, cube, DSO, a data source, 2 transformations, and a bit of 3.x. And basically then I can go onto the second sheet and immediately get those 10 objects presented to me. There's a bit more information on the right-hand side to actually help with the review of those objects. I'll just go back and filter on another one before I go into more detail. So this was a very simple data flow. If I go to this one here, you can see it's a bit more complex with 147 objects linked to that multi-provider. And here then I can see there's a lot more information on the right-hand side. And the idea here is that this information provides everything in a nutshell that is required to actually review the objects. So for example, for DSOs and cubes, you have essential information like the last load date, the size of the object, when was it brought into production, when was it last changed. So basically everything that is required to do this review. There's quite a few more sheets in here, the blue ones, and the first one here is the DSO ABAP lookup sheet, which basically addresses one of the main concerns that we get from customers, which is how can you delete this DSO? The active table might be used in an ABAP lookup somewhere else in the system. That's how we address it. We basically do a check in SE11 to see if there's any lookups on the active tables. You can see there's quite a few here. We produce then commentary on those lookups and for the model owners to review in Grundfos's case. The next sheet here is the keepers. I mentioned them in the slide. So basically those are objects within this inactive data flow that are also used in active data flows. In this example, it's 2 cubes and 1 DSO. So basically the engine logic would stop at those objects and then not add them in the decommissioning list. Additionally, on the other blue sheets here, there is more information on certain object types, for example, on the queries that we have on the list, and so on. So that's kind of the first part of the D2 process where we have our agreed scope and we produce this file to then provide this overview. And then I talked about the floaters on the slide, and for the floaters we came up with another process. Basically we produce 3 more files, and I'm going to just show one of those, which is the cube floater file. So basically, again, we had initially 1 file to share the floaters result, but we got a lot of objects in there, so we kind of split it across 3. So the first is this cubes file, where we then say we have 78 cube floater objects in the system, and this again shows the dependencies. So you can see for the 78 cubes we have more than 750 linked objects, and again it's exactly the same principle. You can filter on those cubes and then review those objects, and we do that also for DSOs, which then normally covers more than 90% of the floaters. And then we have a leftover floaters file which looks exactly the same and just lists those as well. So the next step in the process is then that we get those files reviewed. We have those approvers, could be different people in the company, that then go through this list and basically indicate whether we can decommission an object or not. And then obviously we as SeaPark could do the deletion, or the client themselves. Just a further point, of course, is you've seen on Donald's slide earlier that there's a tool called TunnelSphere, which determines the migration scope to DataSphere. And basically this D2 logic is working the other way as well. So if we flip this engine logic, it can actually tell us what are the objects linked to active data flows that we actually want to migrate out of BW into DataSphere. So that's just the second use case for the engine logic. Thank you very much for listening.
Thank you, Dominic. If you're migrating your current SAP BW solution to either BW for HANA or DataSphere, please consider using SeaParks BW migration tools. Thank you for listening.